Alrighty, here we go. Unit 8, Lesson 3. We're going to be analyzing geometric sequences and series. So, a geometric sequence is when you have a ratio that is constant between two terms. So, let's see here. The ratio of any term to the previous term is constant. So let's take a look at that. So like if I had the two different series, let's say we have 4, 10, 18, 28, 40, and then we also have 625, 125, 25, 5, 1. So if I look at this first series, again, what I'm going to do, I'm going to number them. Here's A1, A2. Here's my third term. Here's my fourth term. I'm going to take the second term and divide it by the first term, which gives me 10 over 4, which is 5 over 2. And then I'm going to do that with the third term over the second term, which would give me 18 over 10, which is 9 over 5. And then just for good measure, let's do the fourth term divided by the third term, which is 28 over 18, which equals 14 over 9. So I'm looking at this number, and this number, the ratio, and they are not the same. So this would be no, it is not geometric. Whereas when I do the same thing down here, I take my second term, which is 125, divided by my first term, which is 625, and I get an answer of 1/5. And when I take my third term and divide it by my second term, I get 25 over 125, which equals 1/5. And if I were to do it again a fourth time, a to the fourth divided by a to the third, that's going to be 5 over 25, which is 1/5. So when I look at these ratios, I find that, hey, these are all the same. We call this a common difference. So yes, this series is geometric because we have a common difference that is the same. So again, kind of like your rules for geometric sequences, or kind of like the generic way that we write it, is the nth term of a geometric sequence with the first term a of 1 and a common ratio r is given by a sub n equals a sub 1 multiplied by r n minus 1. So again, this is for a geometric sequence. This is like our standard setup. So if I had to write a rule for the nth term of a sequence and then find a specific number, I could absolutely do that. So if I had the sequence 4, 20, 100, 500, again, 20 divided by 4 is 5, 100 divided by 20 is 5. I can see that my common difference is going to be 5, and my first term is 4. So if I'm just filling in my equation, I got 4, and then I just found that my common difference was 5, and then it's n minus 1. So say I wanted to find the seventh term, I would say a sub 7 equals 4 times 5, 7 minus 1, which is 4 to the 5 to the 6th power. And plugging that in to my calculator, it's going to equal 62,500. So again, I can write a rule for my equation or my sequence. I can find specific terms after I've written the rule. Another way you might have this question phrased is write a rule given a term and a common ratio. So I might just say one term of a geometric sequence is a sub 4 equals 12, and the common ratio equals r equals 2. Now, again, I want the first term, so I guess That's the fourth term. So what I can do though is I can work backwards. So instead of multiplying by 2 to get the 5th, the 6th, the 7th, I can divide by 2. So a sub 3 is 12 divided by 2, which is 6. A sub 2 is 6 divided by 2, which is 3. And a sub 1 is 3 divided by 2, which is 3.2 or 3 over 2. So I know that, hey, I've got 1.5 for A, and then my common ratio of 2. So A sub n equals 1.5 or 3 over 2 multiplied by 2 to the n minus 1 power. Write a rule given 2 terms. So say I'm only given a few terms. I may have to, do some math first before I can figure out what my R value is. So let's say that the information we're given is a sub 3 equals negative 48 and a sub 6 equals 3072. Okay, so now I'm going to say, all right, I'm going to set up 2 different equations. So I'm going to say a sub 3 equals a1r to the 3 minus 1, which again, we can just call that 3 squared or r squared. 3 minus 1 is 2. And then a sub 6 equals a1r. 6 minus 1 gives me 5. And I know that these are going to equal negative 48. And this one's going to equal 3072. So now I'm going to solve the system. So I'm going to say, all right, well, let's pretend I want to get A1 all by itself. So I'm going to divide by r squared on both sides. So I have negative 48 over r squared equals a sub 1. And then I can plug that in to this equation. So I'm going to take what I just found right here and plug it into this equation. So I'm going to be left with 3072 equals negative 48 over r squared, and then that's going to be multiplied by r to the 5th. Remember your exponent rules. R to the 5th over r squared. Those are going to simplify and cancel out, and the ones on the denominator are going to cancel out. 5 minus 2 is 3, so I'm left with r to the 3rd on top. And now I'm just going to simplify. So again, separate my left and my right, divide by negative 48, divide by negative 48. So 3072 divided by negative 48 is negative, let's see here, 3072 divided by negative 48. I get negative 64 equals r to the 3rd. So I'm going to take the cubed root. Get a different color so we can see. I'm going to take a cubed root of r and the cubed root of 64, and 4 times 4 times 4 is 64, but I need negative, so it's going to be negative 4. Again, I knew that I was going to have a negative for my r because this number was negative and this number was positive, and the only way you go from negative to a positive is multiplying a negative times a negative. So it looks like I've got enough here to write my equation. So a sub n equals my first term. I guess we still got to figure out our first term. If I plug it in, so I can use this number now that I found, and I'm going to say, okay, I'll pick either one of these. I'm going to pick this one just because it's a smaller number. So negative 48 equals a sub 1 times negative 4. 3 minus 1 is 2, which gives me squared. So negative 48 equals 16a1. Divide by 16, divide by 16. And we get negative 3 equals a1. So these are the 2 pieces of information I need to write my rule. A sub n equals my first term multiplied by my common ratio. And then I have to do n minus 1 on z top. Now, if you have a geometric series, which again, you're adding up all of the series together. So you are going to take your first term plus your second term plus your third term plus your fourth term. It's very similar to arithmetic, but again, geometric has a common ratio. The sum of a finite geometric series looks like this. To find the sum, you take your first term and you go 1 minus r to the n on the numerator and 1 minus r on the denominator. And again, all you're doing is you're taking each individual term and adding them up. So if we to look at an example, let's say find the sum of the geometric series I equals 1 all the way to 16. Let's call it 4 times 3 I minus 1. So first things first, I need to identify the first term of my series. So again, if I were to plug in a 1 here, a sub 1 equals 4 times 3. 1 minus 1 is 0, so 3 to the 0 is just 1. So 4 times 1 equals 4, so a sub 1 equals 4. So that's my first term, and then I got to find the common ratio. So if I look for the second term, okay, if I plug that in, I'm going to get 12. So I know that, all right, if I take A2 divided by A1, 12 divided by 4 equals 3. So that means my common ratio, R, is 3. So I've got the two pieces of information that I need. So now I'm going to fill in my equation. The sum of the 16 numbered series is a sub 1, which is 4, 1 minus r to the nth power is 3 to the 16th power all over 1 minus 3. Again, most likely going to have to use a calculator to do 3 to the 16th power and to simplify, but once you do and you plug it all in, you should get the sum of the 16 series, the geometric series is 86,093,440. 86,093,440. There you have it.